267. So we're going to take a step back for a sec here, just the beginning here. Talk about notation that you did in grade 10. Functional notation. Math. Functional notation, which is, if you remember grade 10, this f of x stuff. It is the same as y, okay, except a function, if you remember. Now, this isn't integral to understanding what we're about to do, but hey, we're here, so I'm just going to give you the definition again. A function has only one y value for every x or input. You put in a number, you only get one number out. A relation, you can get two or more numbers out, okay? So graphically, what that represents is, if you remember something called the vertical line test. That's a different type of test. So if you have, say, it's sort of a circle and ellipse there. You try to draw a vertical line. If you hit the graph at more than one spot, it is not a function, because this says, if this is a 1, say, I put in 1, I get two different y values, okay? I get this one and I get this one. So this is not a function. Not a function. It fails the vertical line test. Whereas if I do something like this, again, I'm not testing any of this, but I'll just do a parabola because that's what we're going to do. That's a parabola. If I try to draw a vertical line, I can only ever hit the graph at one point. When you put in an x value, you only get one y value out. That's the definition of a function. That's why they represent things by, instead of writing y is equal to 4x minus 8, they'll write f of x is 4x minus 8, because it means it is a function. And it doesn't, for this level of math, it's the same as y. And most kids are like, what do we need to know this for? This is pointless. But it has implications when you go on to calculus, all right, and higher level stuff. That's why they use the notation. They're just introducing it to you now. The thing that we have to be aware of is whatever's in the brackets here, in for this x, gets substituted into x. So if you look at this one, if our function is 4x minus 8, and I say, what is f of 5? The 5 in here goes in for the x, okay? So even in math 10, you would have seen something like this. If I use the same function, if I said, what is f of x minus 2? Where does the x minus 2 go? It goes in for x. It goes right in there, so you would end up with 4 times x minus 2 minus 8. Whatever's in those brackets gets put in for x, okay? All right, that's my spew on functional notation, because you're going to see a lot of the notation. All you really need to remember is it's the same as y, okay? All right, zeros of a function. Zeros of a function are what make the function 0, hence the name zeros of a function, okay? So these are what x values make the function, all right, f of x equals 0. So if I say, here's our function, 7x minus 21, what is the 0? I go, okay, f of x has to equal 0, therefore 7x minus 21 has to equal 0. And then you just solve for x. That's all you're doing when you're finding the zeros. So what's the answer for this one? 3, right? You'd move the 21 over and then divide by 7, and you'd get x is equal to 3. Okay, so the 0 of that function is 3. Let's go to page 270, please. 270, this page right here. Okay, here's our graph. This shape is called a parabola. And this is what we're going to study for the next week. All right. Parabolas occur when you have a quadratic function. We'll talk more about this in the next lesson, i.e., the highest degree is 2. If the degree of your function is 2, it's called a quadratic. We've been solving them. But now we're going to look at the graphs. The graphs are always this parabola-shaped graph, okay? All right, what are the x-intercepts of this function? Just looking at the graph. Where does it hit the x-axis? That point and that point. What are those numbers? -2 and 3. Okay, what's the y-intercept? Where does it hit the y-axis? -6. Remember, this is the x and this is the y. Okay, so, and it's this function. This is the actual function. Now, if I said, what are the zeros of this function? That is taking the function, setting it equal to 0, and then because that's a quadratic, we would factor it, all right, just like we did on the test. So if you have this and this, what makes this bracket 0? -2 and 3. Now, another word or notation, I'll say word, definition, is if you take the function and set it equal to 0 from the beginning, we call them roots. This you solve just like you did over here. You would factor it. You'd get x plus 2. X minus 3 is equal to 0. What is x equal to? -2 and 3. So these are all the same numbers, right? So what we can say is, and we'll do it at the top. The zeros of the function, the x-intercepts of the graph, and the roots of the equation y is equal to 0 are the same numbers, okay? They're all the same thing. If I say 0, x-intercept, or root, they mean the same thing. I mean, they don't mean the same thing. They're slightly different, but the numbers are the same, okay? So we can use this to actually graph functions, to graph quadratics is how we're going to do it. So here's our function. 2x squared minus 7x plus 3. I want to figure out the x-intercepts of this graph, okay? The x-intercepts are the same as the zeros and the roots, okay? So essentially, you take your equation, you set it equal to 0, which it already is, and you solve it. What type of equation is that? It's a quadratic equation because the degree is 2. How do you solve quadratic equations? You factor it. So we're ignoring this stuff. So I take 2x squared minus 7x plus 3 is equal to 0. How do I factor this? What type of factoring is this? Multiply the first and the last. 6. What multiplies to 6 and adds to -7? -6, -1. So I split up the middle term. And then you bracket. Take out -1. And then you get 2x minus 1. X minus 3 is equal to 0. So what are the solutions for this? What does x equal? What makes each bracket equal to 0? And and 1 over 2. Okay. Those are your x-intercepts. Okay. So on the graph, we have an x-intercept of 3 and 1/2. So let's mark it there. 1/2. Okay. I want to know do it down here. Find the y-intercept. Okay. When you're finding the y-intercept, it's along this y-axis here. It's when x is equal to 0. So all you do to find the y-intercept is put x equals 0 into your equation. Okay? So our equation is this. Put 0 into it. And you're left with 3. Basically, when you have a quadratic, the y-intercept is always the constant term. We're going to talk more about this in the next lesson, but it's always the constant term. Okay? So we have a y-intercept of 3. 1, 2, 3. Okay. This is a quadratic, which means it has the shape of a parabola, like that. Okay? It has to go through these 3 points. So the graph looks like this. That's it. Okay? So if you can find the x-intercepts, you know the shape, general shape of the graph, and we're going to talk more about the general shape and how to, like, what is this point here? We're going to learn how to find that point and stuff. But for you right now, quadratic is always a parabola. Find the x-intercepts, find the y-intercept, and do a quick sketch of the graph. I'm just going to do one more example, have you do a couple, and then it'll be break. And then we'll move on to the other stuff. Are there any questions about that so far? I went through that like at Mach 10. Is that okay? All right. Let's do these ones down here. Okay. We're going to find the zeros. Remember, zeros are the same as what? X-intercepts. Okay. And we're going to find the y-intercept, and then we're going to sketch it. So, for A, the x-intercepts. Take your equation, set it equal to 0. How do you solve this? Factor it. What can I do first? Take out a 5. Yes, you want to. I mean, you don't have to, but it's going to make your life way easier if you take out a 5. All right, so now we're looking for numbers that multiply to -4 and add to 3. What are they, peoples? There you go, -1, +4. So what does x equal? What are my x-intercepts? There you go, -4 and +1. Okay. The y-intercept, in green, that's when x is equal to 0, right? So what number you just have to look at? Negative 20, because that'll go away and that'll go away. It's negative 20. All right, so we can do a quick sketch of the graph. So we have y or x-intercepts of negative 4 and 1. We have a y-intercept of negative 20. Just guess where negative 20 is. I don't really care. I'm just looking for a general shape here. It's got to go through those 3 points. What is the shape of a quadratic graph, quadratic equation? It's a parabola. It looks like that, right? They always look like that. So there's a general quick sketch of the graph. All right. Is that okay? Find the x-intercepts. Set it equal to 0, which means you're going to factor it. And then find the y-intercept, which is just the constant term. What's the y-intercept for this graph here? 10. What's the y-intercept for this? So this one it's already in factored form. So if you want to find the quadratic, it's not 1. If you want to find the y-intercept, if you multiply it out, you'll get 4x squared plus 2x. So what's the y-intercept? 0. Okay, so just be aware it would be 0. All right, I would like you to do questions, and that'll bring us up to break in 10 minutes. Numbers 3 and 4. 3 and 4, please.